All right, so now we're going to talk about reverse area models for division. So area models for multiplication, we're going to essentially, if we have a rectangle, and one side of my rectangle, say, is 15 units, the other side of my rectangle is 7 units, then I know to find the area, the space here in the middle is just 15 times 7, and so that would be, in this case, 105. So 105 is the area in the middle, so that's why it's called an area model, and that's how that works. So we're going to use that kind of same idea for division. We're just going to use it in reverse. So for example, if I had a problem of 2,507 divided by 23, then I know that I could model this with a rectangle. Now I'm going to leave part of it off because I don't know how long that rectangle needs to be. I know one side is 23, but I don't know the other side length. I do know that the inside, or the area, the total amount is 2,507, but I don't know the other side length. And so that's what I'm trying to find out in order to have this work. So it kind of works like fact families, multiplication and division. They're inverses of one another, and so we're going to see how this works. Now, I know the total amount is 2,507, so I need to get pieces of this that total up to that. We're going to do a very similar concept soon using number webs, but in the meantime, this works almost as well. So if I'm going to look, 23 times something needs to fit inside of this amount. So I know if I had 23 times 10, that's going to get me 2,300. So there's a chunk of it there. That's 2,300. So I can subtract that from what I have. That's going to give me 207 remaining. So 207 remaining, and I need to know how many 23s fit in 207. I know it's less than, oh, I'm sorry, that's not a 10, that's 100. So I know it's less than 10 because that would be 230. So it's got to be less than 10. So let's see what 5 is. So if I had a chunk that was 5 on this side, 5 times 23, and that's going to give me 115. I need to subtract my 115 from my 207, which is going to give me a remainder, or what's left, of 92. So I have 92 that I still need to use up. So how many 23s are in 92? I'm not sure. I know if I had two 23s, that's going to give me a chunk of 46. So I'm going to subtract that. That leaves me with 46. Oh, well, good. I know that another 2 will get rid of that 46 or use that up. And then now I'm done. So almost there. And so we see here, this is going to be my answer, is this side length. I know this side length is 23, and then this side length. So 100 plus 5 plus 2 plus 2, so my answer is going to be 109. Now I could also do this using the standard algorithm. That would also work. So 2507 as my dividend, 23 as my divisor. How many 23s are in 2? 0. How many 23s are in 25? 1. 1 times 23 is 23. Subtract. I check, is 2 less than 23? It is. Bring down my 0. 23s and 20. There is 0. Bring down my 7. How many 23s are in 207? And it ends up being that there are 9. 9 times 3 is 27. 9 times 2 is 18. Plus 2 is 19, 20. And that works as well. So standard algorithm does work. But in the meantime, if you're not real comfortable, you're not real strong with the standard algorithm, then the reverse area model works. And then when we start doing number webs in the coming days and weeks, then there's a method there that works equally as well. Next one, 1,170 divided by 15. So of course standard algorithm will work. We'll do that one first. We'll do it in reverse order of the last one. So a dividend of 1,170, 15 is my divisor. How many 15s are in 1? 0. How many 15s are in 11? 0. How many 15s are in 117? So I'm not real sure, and so I'm going to have to kind of do some trial and error, some guess and check maybe. I know that 4 15s is 60 from a clock, right? So 15 minutes times 4 is 60 minutes. So I know that 8 15s will give me 120 minutes. So it's got to be less than 8. So we can do 7. 7 times 15, we'll see, will give me 105. Subtract, so that's going to give me 12. 12 is less than 15, so it does check. And then now, how many 15s are in 120? Oh, I know that's 8 because we just talked about that with the clock. 8 times 15 is 120, and I do have my answer. So standard algorithm does work, but I could also do the reverse area model. So I know that I have a rectangle. Again, I'm leaving one side open. I know that one side length is 15. I know that the whole thing is 1,170, and I'm trying to find the other side length. So here, if I did times 10, that would be 150, so that would work. That fits in there, so let me subtract that out. So I know I have a chunk of 150. If I know a chunk of 150 is 10, then if I did a chunk that's twice as big for 20, that would give me 300. So let's see, 300 definitely fits in here. So 10 minus 3 is 7. And so there we go. Oh, well, I can fit 2 of these 20 chunks in here. I can get 600 in here. So let me drop a 40 here. So 40 times 15 is 600. That's what we just talked about, because I'm just doubling this each time as long as the pieces still fit. So now I can subtract 600 from 720. That leaves me with 120. And let's pretend for a second I didn't know what 120 divided by 15 is, and so we're still, let's say we're still guessing, just going on what we know. Well, I know 4 15s is 60. So 4 times 15 is 60. So I'm going to subtract 60. That leaves me with 60. Oh, I know I can do that again. Another 4 and 60. So then my answer is going to be, or my quotient, is going to be this side length. So this side length, 15 times this side length, is going to give me 1,170. If I add that together, that's 1,170. And so if I add this together, that's going to give me my quotient. So 10 plus 20 plus 40 plus 4 plus 4. So 40, 60, 70, and then 4 plus 4, 78. So then my answer is going to be 78. So using the reverse area model in order to do division works just fine. Again, when we start doing number webs, I kind of like number webs a little bit better. It just really depends on what your preference is. So maybe you'll like the area model better. Maybe you just like standard algorithm. That's fine too. Just wanted to give you some different methods.